Let's do another assessment. Here. So given an integer and return true if it is a power of 2, otherwise return first. Here, solve it without loops or recursion. Without loops or recursion. I mean, if it is a power of 2, then big count equals 1. Maybe I can do it in Python, but I need to check. End of big count, return end of big count equals to 1. So if it is exactly 1, then it means that it is the power of 2. True. 16 is true. 3 is first. True first. Submit. Negative 16 is true. Wait. So abst. Yes. This is pretty tricky. I didn't realize that negative input is also accepted. True. Let's try again. Oh, it should be force. Hold on, why is this force? This is the power of 2. It's an integer. So wait, hold on. So if n is less than 0, then just return force. Is that it? Because n equals to 2 to the power fixed. So what if, I don't know, what is like 2 to the power of negative 3? Okay, so you can actually reach, oh, of course, you can actually reach negative with negative power. Okay, I was dumb. It should be good enough. Okay, question 2. Given an array nums of n integers, where num size is in the range of 1 to n, return an array of 4 integers in the range 1 to n that do not appear in nums. Hold on, given an array nums of integers, where nums is in the range you may assume the return list does not count as extra spaced. Well, I can just mark the thing as negative, I think. I can just mark, for example, this 4 should correspond to index 3. So 0, 1, 2, 3. So I mark it as negative. Yeah, basically that's pretty much it. And then I iterate again for my n range n equal to length nums. Okay. Nums I minus 1. Times I change I change this index to -1. And then for I in range n, so if nums I is greater than 0, so it means that nothing marked it as negative. So it means that this I plus 1 doesn't exist. Eventually just return result. Hope that makes sense. 2, 3, 5, 6. No, that doesn't make sense. Huh. 1, 1. Oh, because it appeared twice. Of course. Of course. Of course. So if is greater than 0, then we mark it. Otherwise, if it is already exist, there's no point of it to remarking it. Actually, I can just make an extra variable for this. Next. Let's try to run this again. 5, 6. That looks more likely. And it's 1, 1. Okay, 2. Let's try to submit that. So the time complexity is ON. Space complexity, well, it said that it doesn't count. The result doesn't count, and I should also change the input array a bit. I think that's okay as well. Yeah, so I think I followed this. I think I completed this for up as well. And for this, well, I think I satisfied the follow up as well. But I guess under the hood it has some sort of rule in order to check whether how many bits are there. But while theoretically it's not possible to just look at, for example, we cannot skip reading one of the bit. Like for example, this 16, I don't know, the 4th place is turned on. So what if you skip reading one of this? Like I've bit you skip reading that? And what if the one that you skip reading is actually turned on? So that means that you cannot skip reading anything. So that's why the best you can do is just iterate through every bit, but it just depends how you call the built-in function, so you don't have to use the loop. I guess it also check your understanding for the binary numbers as well. I guess that's the point of this question. As for this question, I don't actually know if that is good enough for this, because I actually change the nums. I guess I can play nice. So that is actually change it back to normal. So from the outside point of view, that does not use any extra space, and also the input array is not changed, because while we change some of the numbers to negative in order to tell us whether this index has appeared or not. And after that, before we return the result, we kind of play nice to refer back to positive number. So in that sense, it doesn't change anything on an input as well, so to speak. And also the result array does not count as extra space, so it is O1 space and O(n) time, obviously, because we just do this free for loop, n times 3 equals on times 3 just on. Yeah, that's pretty much it. Let's finish the session. Yeah, today's program was pretty easy. That's it for today.